In this video, we are going to explain the procedure to make the adjustment in order to find the measurement of the capillary tube that guarantees us that the system will have the appropriate. Let's start with the adjustment in low. When we need to adjust the low pressure with the new, we have to see first the difference that we are going to have with respect to what we need. If the difference that we are seeing in the manometer with respect to what we need is less than 5, whether it is 5 psi above or 5 psi below, but it is less than 5 psi, we will always think about the length of the capillary. With the length of the capillary, we can achieve short variations in the low pressure. In fact, the will always modify the high pressure more than the low pressure. But since we are in low pressure, we are going to make the cut of the capillary or lengthen the. If, for example, we have a pressure in the lower manometer than we need, for example, that R is 3 psi below what we need, that means that to raise the pressure at this point we need more gas. Refrigerant, but we need more refrigerant. So for more refrigerant to enter, we have to eliminate the restriction. As we said that we are going to touch, because the differences are small, is the length, then what we are to do is shorten the capillary. How much are we going to cut? Well, tests are usually done with 20% with respect to the total of the capillary. 20% is enough to do the test. Now let's go to the high pressure. When the high pressure that we need to find differs with the in less than 10 psi, then we are also in a short differential and a small differential. Then also to obtain the final pressure, we have to play with the length of the capillary. Why? We are not at the value we need, but we are very close to obtaining it. So the easiest way to obtain it is by playing with the length of the capillary tube. In that case, the pressure that we have is below, the pressure that we are reading in the manometer is below what need, then we need less refrigerant to come out of the capacitor. And for less refrigerant to come out of the capacitor, then what we have to do is increase the of the capillary. Notice the difference between both points. When we want less refrigerant in the evaporator, we lengthen it. When we need more refrigerant in evaporator, we shorten it. But when the differences are less, we leave 5 psi. On the other hand, in the capacitor, when we are going to work with differences of 10 psi to work the length, when we need less refrigerant to come out in the capacitor, then to get less, the length of the capillary. Why? To put more restriction to the output. On the other hand, when we need more refrigerant to come out of the capacitor, then what we are to do is shorten the length of the capillary tube. In that way we are adjusting the final value. Now there is the possibility that the difference is not 5 psi in low or 10 psi in high, but in this case, then we are very far from the optimal point. Then we have to play with the diameter. The capillary. We are not going to play with the length. With the length it is played when we are to reach the adjustment. So there we are going to play with the diameter. When the difference, at least in low, we are to do the example in low, the difference is greater than 5 psi with respect to which we are. Example, we need 15 and in our manometer we are reading 3. Then we are going to play with the of the capillary. If we want more refrigerant to enter the evaporator, we simply put a larger diameter. On the other, if we need less refrigerant to enter, then we put a smaller capillary diameter. For the capacitor, should not play with the length, but with the diameter. If we want more refrigerant to come out of the capacitor to lower the pressure, then we put a capillary diameter. On the other hand, if we need more pressure, that is, more refrigerant in the Then we put a smaller diameter. In this way we can adjust the capillary measures. However, before finishing it is important to mention that the length of the capillary, the capillary tends to affect more the high pressure than the low pressure. The length of the tends to affect more the high pressure than the low pressure, while the diameter of the capillary, both, but it tends to affect more the low pressure. This is important because it can happen that at time of adjustment we need to take into account more variables. See you in another video.
En otro video.